Good evening. Good afternoon, sorry.
Okay.
Because I'm thinking about the dinner, sorry. Good afternoon, be welcome back after. I hope you had a pleasant lunch. And this evening is special because we are going to have 3 special lectures. And yes. This afternoon, sorry, again. I don't know why I think on the evening, because maybe people are going to the game. Sorry again. This afternoon, we're going to invite 3 speakers. Dr. Norbert, that he's going to talk a little about the microplastic pollution in aquatic systems. We also have another professor, Ramiro Echepar, that he's going to talk about water reuse, risks, challenges, and opportunities. And Professor Daniel Alazia Pichli, that he's going to talk about technologies for urban areas. So we are going to follow the same procedure like the morning. The 3 speakers will have around 30 minutes to speak, and we make a break, small break, and after we continue with the questions. So, the first invited is Professor Norbert Tichel. He's the head coordinator of this Wind Exceed project, and he traveled directly from Shanghai to São Paulo to give this speech and to meet us here. So we appreciate your efforts to be here this afternoon, today with us. And I have my bio about Professor Norbert for the ones that doesn't know yet. So he is from Germany and married, 3 children. He was in the military. He studied economics and sociology, also civil engineering. He is also was the site manager of the engineering company. In 1986, he concluded his PhD with the topic of 2-phase anaerobic digestion. He also was a CEO with our design company in Germany with more than 100 employed people in 1994. Since 1994, he's a full professor at the TUBIS, the Technische University of Braunschweig in Germany. He in 2002 was the dean of the faculty, and 2007-2010 he was the vice president of the TUBS in Braunschweig, and since of 1915 he's the head of the Exceed project. This project that you are participating. And he's looking forward for his retirement in October 2019, right? So, please, Professor Norbert, it's a pleasure to have you here, and the word is with you.
Thank you very much, Elvis, for this friendly introduction. Good afternoon, ladies and gentlemen.
Yeah.
Elvis is always ahead his time. That's the reason why he always says good evening. At first, I must tell you that I'm very glad to be here again, to join you, to join this workshop. I like to be in Brazil because of the people, of the food, of the music. It's a wonderful country. And I like to be the head of Exceed because I always have to do with young people, and we always working in a very good mood. Today I also will be a little bit like Elvis ahead because I will speak about plastic pollution in aquatic systems. It's named Problems and Solutions, but I will more or less speak about problems because up to now we don't have really solutions for this problem. We made first steps, but at first we have to learn what happens. So if you look to the newspapers, you see articles about ice in the sea, samples taken from 5 locations found concentrations of more than 12,000 microplastic particles per liter of sea ice. 12,000 per liter. Most important for me, plastic particles found in bottled water. I've read that in a small plastic bottle of water you can find up to 200 plastic particles. And we drink this day by day. No one knows what it affects. Sea salt around the world is contaminated by plastic, as studies show. So some people pay a lot of money for pure sea salt. But isn't it pure? Or is it? It's plastic salt. What are the facts? The plastic production worldwide is shown in this picture. Starting 1950s, nearly 0 tons of plastic were produced all over the world, and now we are speaking about more than 300 million tons of plastic worldwide. You can also see that we have a stagnation in Europe or even a small decrease, but worldwide we become more and more plastic products in our environment. European plastic demand market sectors in 2016 are shown here. 40% of the plastics we use for packing, 20% for building, 10% for automotive. The rest is electronics, household, leisure, agriculture, and others. Here you can see what kinds of plastic we are using. PET, PUR, PVC, and so on. And thanks God, the PVC is going back, because PVC, there is a lot of chlorine to produce it, and that's very bad for the environment. So in this picture, I've shown in the lower part the plastic circle. You can see here the primary production, the use in our society, and the biggest part is discharged of the plastic material. And please take in mind, half of the produced plastic becomes waste within 4 years, not longer. If you take plastic bags, as you use them while shopping somewhere, the lifetime maybe 1 day, nothing more. 2.5 minutes. Yeah, 2.5 minutes. So when I dealt with this problem, I personally stopped immediately to use plastic bags. From one day to the other, I rejected to use them. In before, I didn't think about this point. And you can also see in this picture, you have only a very small part that is recycled. Every politician speaks about recycling. Everybody thinks, okay, we sample it separately and bring it back in order to recycle it. No, only less than 10% are recycled. So we divide the plastic in our environment when it's a liter in macroplastic, mesoplastic, and microplastic. Macroplastic has more than 25 millimeters, mesoplastic 5 to 25 millimeters, and microplastic less than 5 millimeters. I think these 5 millimeter particles you will see are not the problem. The problem is the very small microplastic, which is smaller than 1 millimeter or even in a direction of 50 micron or something like this. Actually, the analytics defines lower limit mostly 10 to 20 micron. And that is a material that is important. Also, ladies and gentlemen, I speak today about microplastic. In my opinion, that is only the first step. In future, we will get bigger problems with nanoplastic, which is much smaller and is more dangerous for human beings and for animals. But Elvis has told you that I will retire next year. The problem of nanoplastic is a problem you have to solve, not me. Okay? So marine litter, another problem. That is any solid material that was found its way into the marine environment, and you can see in this picture, this boat is swimming on plastic and not on water. It's transported by the rivers, the drainage overflows, sewage system, wind, and deliberate disposal. It accumulates at the sea surface on beaches or on the sea floor. Up to 95% of the marine debris are plastics. Remember the thousands of tons of plastic we have already produced worldwide, and a big part we can find nowadays in seaside. Fishing and tourism industries are affected. It travels long distances, so it's of global importance. In this map you can see the hotspots where we nowadays can find plastic accumulations, and no one knows up to now, there are first steps, how to get rid of this problem. Because most of these plastics cannot be degraded by bacteria, a little bit by sunshine, but that's all. So, looking to the microplastic, we have to look at primary microplastic and secondary microplastic. Secondary means it's plastic breakdown by chemical physical impacts. If big parts come into the environment by the time, 5 years, 10 years, 20 years, they were destroyed, the big parts, and become small parts. But also the primary plastic material, it's targeted production, granular pellets, for example, for cosmetics, for sandblasting. So the biggest pollution from this primary produced granulars and pellets are the ladies, cosmetics, if you use cosmetics, peelings, microplastic ladies. But we have also other sources, such as chemical fibers from textiles, tire abrasion, loss of granular during production and processing of plastic, and last but not least, the cosmetics, washing agents, plastic abrasive, toothbrush, and so on. How does it enter the aquatic system? It's very simple. We have a source of water, bring it to the households and the industries. We distribute it, we consume it, and at the end, at this point, it's spoiled by microplastic. What is the relevance? Plastic waste and microplastic have been detected in water bodies, in sediments, and at the coast. Animals take plastic waste or entangle themselves in it. Injury of digestive tract, obstruction of digestion, blockade of food intake, toxicity. Some of the microplastics have hormonal effects, pollutants, invasive species, pathogens, and others adhere to microplastic particles. So you can see all the bad things have a big affinity to the microplastic, and that means also to the food chain through fish to human beings. Sorry. So up to now there are several studies made about the content of microplastic in different water sources. The Oldenburg East Frisia Water Board in Germany, the city of St. Petersburg, a wastewater treatment plant in Scotland was observed in 2016, one in Finland, and in 2018 research was made on rivers in Germany in order to look how much microplastic is in it. Here you can see the number of publications about the topic microplastic, and it starts in, let me say, 2015 or something like this, while scientists become more and more interested in this topic. So here you can see the study of the OOWV in 2014. They made a filtration of a big water volume by stainless steel candle filters with a mesh size of 10 micron. They looked at the effluent of 12 wastewater treatment plants in the area. 300 to 1,000 liter treated wastewater was analyzed. And let me come to an end. The number of microplastic particles they found after a quite normal mechanical and biological wastewater treatment was in between 80 and 700 roundabout per cubic meter. The method they used was a micro Fourier transformed infrared. It's shortened FTIR. And you can see later on that other researchers used different methods. In the sewage sludge, they found up to 10,000 particles per kilogram dry solids. That's clear. If I have a normal mechanical and biological wastewater treatment, it's the idea of this treatment to get out the pollution of the water into the sludge. Therefore, the number in the sludge must be high. But at the end, the efficiency is not enough if you have 700 particles in 1 cubic meter water. So one has to think about what can we do in order to get a better purification with respect to this topic. The studies in St. Petersburg were a little bit better, in my opinion, because they didn't look only on the effluent, they also looked on the influent. They had 3 sampling points: influent, after the mechanical treatment, and after the biological treatment. And here you can see the effect of textile fibers, synthetic particles, and black particles. Black particles, they mean a special plastic material. The sampling method was different. They had transparent plastic tubes. I don't think that it is the best way to analyze plastic and using plastic material to catch the sample. They had 3 filters, mesh size 300, 120 micron, and they looked on a light microscope and were optically counting and identifying the material. So quite different from the first one. So the Scotland studies showed a removal, let me shorten it, of 98.41 of the incoming plastic, microplastic, so a high removal rate in the effluent of the wastewater treatment plants. They also use CFTIR to identify what kind of plastic material it was, and they also used a microscope to show what are the different plastic materials were like. No. So the river studies in Germany, the results are given here. We had a filtration of 50 centimeter down from the water surface. On the water surface you can find much more particles than I will show you now, but that's not interesting. One could fish it. But which is lower is more interesting because it affects the environment. So they had a special sampling equipment called mini mantratrol. That's a net with a mesh size of 300 micron that follows a boat. They destroyed the rest of organics in the sample by enzymatic reaction. and the analytical equipment was also the FTIR. The results from 2.9, that means 3 particles per cubic meter in the Rhine, we had results up to 240 particles per cubic meter in the river Emscher. It's very sensitive. So if I try to find some conclusions of the studies and looking on the sample volume, it's completely different. The sampling equipment, it's completely different. The sample preparation, completely different. Enzymatic, optical, centrifugation, Fenton reagents, vacuum filtered, enzymatic. The analytical equipment is different, and the microplastic particles they measured are also different. What does it mean? We need somewhat a worldwide standardization. Otherwise, we cannot compare the results. For example, we measure in Germany, or you're in Brazil, or in Egypt, or somewhere else. But I've shown you that the academic discussion started in 2015 or something like this. So I'm hopeful that within this and the next year we will get a standardization, because in Germany we work on this together with our partners from the European Union. So once again, a comparison between the methods. Let me wrap up the conclusions of this studies. The microplastic can be found in surface water, coastal water regions, wastewater. They are nowadays all over the globe. At the moment, there is no standardized sampling, preparation, and analyzing. The sampling requires a lot of sample volume. The sample preparation and analysis takes up to 1 week for one sample. Most common is the FTIR. The result you get are the number of particles. We have a big discussion actually if we should give as a result the number of particles or the content in milligram per cubic meter. Andreas votes for milligram per cubic meter. I vote for particles. No, I vote for both. I will give you a very simple explanation for it. If you have 1 milligram per liter, it may be 2 big particles which you can get out of a sieve. It also can mean you have 1 million small particles which you can not get out with the sieve. Therefore, we need both informations. How many milligram per liter is in the water and how many particles do we have? And if possible, what is the size of these particles? That would be the best information. So actually we work on the guideline, and quite common wastewater treatment plants show a reduction between 96 and 99%. But we don't know if this 99% is enough. I guess not. So it's necessary to have further investigations on the wastewater and also on the sludge path in our treatment plants. So what are the possibilities for the reduction of the plastic material at seaside? Collection at the coast. It's done in many regions all over the world where we have tourism industries, because if I go for holidays on the beach and there would be a lot of plastic, I would reject to go there and looking for another place which is nicer. From the ocean, in Belgium and in the Netherlands, they started first steps to get rid of the problem. Boats of the fishermen of Belgium are equipped with a special trawl net to collect floating plastic. This waste is then converted into bottles for ecological detergents with red dot design. It's the first step. A young guy of the Netherlands stopped his studies. He wanted to become an engineer, and when he was faced with this problem, he said, I know enough. and he started to build stationary filter at 5 big garbage patches, 1 to 2 kilometer long, solid screens, mesh-sized 1 centimeter. This is okay for marine litter, but not okay for microplastic, because 1 centimeter will pass through. The problem by taking out plastic is to remove also adhering microorganisms and aquatic organisms. You cannot avoid this. So what can we do in wastewater treatment plants? We have a mechanical treatment. We can absorb it to the sludge matrix, the results you have seen. That means up to 99% comes out of the water and goes to the sludge. If we use a membrane filtration or a membrane bioreactor, we can be sure that for the microplastic we have solved the problems, not for the nanoplastic I mentioned in before. Flocculation may be a solution, a downstream filtration with a mesh size smaller than 100 micron. And what is also possible is the adsorption on activated carbon. That's what we know now. The German Federal Ministry of Education and Research initiative called Plastic in the Environment Source Sinks Solutions. That is an umbrella initiative, and they gave money for altogether 18 projects. And my institute has one of these 18 projects. The name is REPLAVA, reduction of the input of plastic via wastewater into the aquatic environment. And we will investigate during the next 3 years the pathways in treatment plants, stormwater drainage, combined sewer overflows. We will have a look on groundwaters, especially in the area of Braunschweig. In Braunschweig, we have a speciality. The purified wastewater is used in agriculture for irrigation since more than 100 years. And if we look to this groundwater, we can be pretty sure what happens, if there is an effect or not. We will also look at the agricultural land. We will find practical methods of reducing and eliminating the plastic into the waterways during the water treatment. And we have different strategies for reducing plastic release into waterways from wastewater treatment, for sensiting policymakers as well as plant operators to this problem. This is a test plant we have built during the last months. It will start to operate next week on Tuesday. This is a typical mechanical, biological. The mechanical is not shown, the biological treatment. These are the final clarifiers. And there we have different filtration units, sand filtration, a activated carbon, and a microfiltration, and so on. And we will look what will the output be. And furthermore, we take this sludge to digest it and to look what happens during digestion. This has a size of 500 population equivalents, and you can imagine, I told you in before, to take one sample and to analyze it needs 1 week. We will not get results within 3 years. Therefore, we are using a trick. We are not looking at the microplastic that is natural in the wastewater we are using. We are adding special microplastic we can detect very easily. And therefore, we hope to get good information from this test plant. Here we have a mechana filtration, a membrane filtration, a Nordic water filtration. You can use it with sand or activated carbon. So different machines are tested. Another solution might be a complete different way. Animals may be a solution. One has observed that mealworms fed with styrofoam and polystyrene are able, for example, 100 mealworms within 40 24 hours can consume 30 to 40 milligram microplastic. They consume it and degrade it into carbon dioxide, depolymerized metabolism, and 0.5 biomass. The larva of the wax mouse feeding also PE. 100 wax worms in 12 hours can feed 92 milligram plastic material, but these worms don't work in water. And up to now, we couldn't find any animal in the aquatic system which is able to destroy plastic. So, in my opinion, political regulations can help to find solutions or to minimize the problem a little bit. Up to now, the politicians did not take care of this problem. Ban of plastic bags in many countries is started in Africa in 2008 in Rwanda. That's a very good approach, in my opinion. Recycling rates of cans and not reusable bottles are 90% in Germany, not worldwide. Worldwide, it's less than 10%. And so on. Some materials are banned in India. In the European Union, we discuss a ban of single use of plastics. For example, straws, cotton buds, and so on. In the map you can see here, the green colored means that plastic bags are politically banned. You can also see which country is this? No one knows, okay? Yes, in Tanzania it works. Last week I gave this presentation in China. You can see in China it's banned, but wherever you go, you get plastic bags. Hundreds, thousands. Rwanda, I already told you it works, and our colleague from South Africa, it's also banned. Do you have plastic bags, yes or no?
We have them, but you have to pay for them. So they're being phased out. They don't get given out free.
Okay, but you still have it. Yeah. So you can see first countries have made first steps, and the only country where it works very excellent is Rwanda. And we have to look there to learn. So, in my opinion, every person shall begin with him or herself. What can we do to avoid buying items packed in plastic? Use close shopping bags. Skip bottled water, carry a reusable canteen. Upcycle. Think of new uses for old items rather than discarding them or buying new ones. Bring a reusable mug when you order coffee. Say, no straw, please. Wear clothing made from natural materials, such like cotton and not synthetics. Avoid disposable tableware or use the compostable kind. Don't just discard electronics. Bring your own container for takeout and leftovers. More, I don't know about the topic, but perhaps in 2 years I know more. Thank you for your attention. Who's next?
Thank you so much, Professor Norbert, for this great view, this great panorama from all sizes of plastic, from the litter, from the oceans to microplastics, its effects and how to treat, detect, treat, avoid it. We still have a lot of work to do. I'd like to invite the next speaker, Professor Ramiro HEPAR. He's an environment engineer. He's a master and a PhD in engineering by the Federal University of Rio Grande do Sul. He works with environment technologies, and his main research lines are in the areas of water treatment for water supply, and wastewater treatment and reuse by physical, chemical, and oxidative process, and in the risk assessment of water reuse systems. He's going to be retired in 2086, right? Okay, so, just a joke. The word is with you.
Many thanks, Elvis. Well, first of all, I would like to say that I'm very happy to be here discussing with you all these important issues on water security. And I would like to say thank you for all the organizing committee, and special thanks to Elvis Carissimi, Marcelo Nolasco. And I also have to say that I'm not alone here. I came with my colleague, Daniel Santos, which I would like to say thank you as well for all your support and partnership. And so the topic of this afternoon would be water reuse criteria and in a Brazilian scenario. I would like to begin with a question. Is water a limited natural resource? If we look by the perspective of biogeochemical cycles, we would say that water is unlimited, but as we saw yesterday in our first presentation of this workshop, we saw that by our law, which dictates the Brazilian national water resources policy, one of the fundamentals of this law says that water is a limited natural resource, which also has an economical value. So why water is limited? So we've been discussing that the main reason for water being limited is because of its scarcity, and scarcity may be presented in two main ways, as qualitative aspects and also quantitative aspects. So it's very important to understand these two aspects. So if we consider the quantitative scarcity, and here we look for a global situation. Yesterday it was shown the Brazilian scenario, where, for example, we saw that most of the water resources in our country are concentrated in the north region, and where there is less people, and most of the population is concentrated in the south or in the southeast, where we have less water resources. And if we have a look on our planet, we see the same very poor distribution of water, in addition to high density population in certain regions, and sometimes these regions are those regions that are facing problems of very little water availability. And we have, for example, a very dramatic situation in Africa, where if we compare with South America, we see that Africa has much more people, about more than 1 billion people, but much less water resources. For example, in Nigeria, and we have people here from Nigeria, will overtake United States in a few years and will be the third most populous country in the world. So we have this big issue here of a very poor water distribution and high density population in a few areas where little water is available. So we also has this problem of population growth, and as population is growing, water demand is also increasing a lot for the multiple uses we have for water, and we see that the conflicts for water uses are also increasing a lot. So we have many different sectors, electric sector, sanitation, tourism, and that's why we have here in Brazil the National Water Agency that's try to mediate these conflicts. But then this multiple uses of water brings us another issue on this quantitative scarcity. One of the methodologies used to analyze the water balance in the river basin is the water exploitation index, which consists of the ratio between withdrawal flow for consumptive uses and the average flow of the river. And this ratio is divided into excellent, comfortable, worry, critic, or a very critic situation. So I would say for the last three situations, we may have in some situation a restrictive use of water. And in Brazil, if we have here some data of the National Water Company, and we see that mainly in the northeast we face water scarcity, and there are many rivers and cities that are supplied by these rivers that are in a critic or a very critic situation. And the worst state is Pernambuco, which is the driest state in Brazil. And here there is a reporting of this year, and like these emergency situations of lack of water are very common. So we have in Brazil, despite its abundance in water resources, we do observe water scarcity in many regions. And when we talk about qualitative scarcity, of course, we are talking about pollution and degradation of water sources, especially in large population cities, in very urbanized areas, in very industrialized areas, where we see mainly the discharge of domestic wastewater. And as we have been discussing here, in Brazil, only 50% of our wastewater is collected, and only 30% of this amount collected is effectively treated. And in addition, we have also industrial effluents and solid wastes that contribute to this degradation of our water resources. A typical scenario that we can observe in Brazil is wastewater treatment plants. We have wastewater treatment plants, or sometimes we have wastewater treatment plants. Only in a few times we have wastewater treatment plants, or maybe we should have wastewater treatment plants. But these wastewater treatment plants discharge their treated effluents in water bodies, and the treated effluents need to meet emission limits with quality standards that are set by our CONAMA. And furthermore, the water bodies are also classified in different quality classes, and these quality classes are set also by CONAMA. So each water class has to meet a specific criteria of quality in order to be used in many different uses. For example, water supply or many other uses. This seems to be a rational approach, a logical approach, but the problem is that sometimes, even if we met the emission limit, for example, BOD of 120 milligrams, even meeting this criteria, sometimes we don't meet the criteria for the water bodies, and this happens especially in situations where we have a very low water flow in the rivers, and then our water supply, our water bodies do not meet enough quality standards so it can be supplied to humans and also to their other uses. So we have a few solutions in this scarcity scenario. It was already been discussed in this morning by Professor Mierzwa. So we have the rational use of water, we have basic sanitation that actually we don't have in Brazil, and we have alternative sources of water, so mainly reclaimed water, and with reclaimed water we can get many benefits like decreasing the volume of water that is abstracted from surface waters, from groundwater, and reducing the amount of wastewater that must be discharged into our water bodies. And also when we consider a planetary scale, we can also have some benefits by saving energy and also reducing climate change. So as main sources, which are the main sources that we have for reclaimed water? We basically have domestic wastewater, plenty of domestic wastewater. We have grey water, which is a separate flow of domestic wastewater, excluding toilet inputs, so a low load of pathogens and maybe organic matter, so easier to treat. We have also urban wastewaters, for example, laundry wastewater, car wash, vehicle wash wastewater. We have industrial wastewaters and very heterogeneous source for reclaimed water. And we have rainwater. So basically what we need is to choose the proper treatment technologies necessary to meet specific criteria for reclaiming and for reusing this water. So regarding these treatment technologies, there is a very important concept that is called fit for purpose, and this figure here shows that the treatment technologies actually offers a certain of ladder of different quality of reclaimed water. So basically choosing the treatment technology will dictate which quality of reclaimed water I need to obtain for an end application. And for that we have basically two main approaches. We can have a high technology, high cost, and low risk approach. For example, as it was shown in this morning, the Aquapolo and Sabesp, which has very high technology, membrane technology, advanced treatments. And we also have another approach of low technology, low cost, and controlled risks, so less restrictive risks and cheaper technology, easier to be applied. And another important issue regarding these treatment technologies is the location of the treatment plant. So basically we have a centralized or either a centralized or a decentralized approach. So centralized approach consists of the largest solution, so small numbers of big units that usually are responsible for the whole catchment area of a whole municipality or very big neighborhood or regions in a city. And the decentralized approach consists of on-site treatment and reuse, so treatment plants that are located very close to the source, to the generation source of wastewater. So they are positioned in the vicinity, in the area of the wastewater is being generated. And of course we have advantages and disadvantages of both approaches. For example, centralized approach may be less flexible, and sometimes, on the other hand, it's easier to manage because there is a small number of units. And in a decentralized approach, for example, we have less vulnerable units because we are talking about many different units. And on the other hand, we may face some issues regarding other, because we are very close to the generation point. We're very close to population, so we may face other issues. We may face overflows, and we may face aesthetic issues. So the best option needs to be evaluated very carefully and evaluated case by case. Regarding regulation, what we have in Brazil regarding criteria and standards for reusing water. Basically, we have one main document that was launched by our National Council for Water Resources, and is a resolution from 2005, and basically it establishes modalities and very general guidelines for non-potable direct reuse of water. And we don't have anything about potable reuse of water. We have only these main guidelines for non-potable reuse. And basically this revolution covers different modalities. It presents different modalities for water reuse. For example, reuse for urban purposes, reuse for agriculture, environmental purposes, industrial purposes, and reuse in aquaculture, for example. But we don't have specific laws, specific standards for each of these modalities, and the reasons for not having these specific laws have many reasons. We don't have for example, a good technical background. There is a lack of technical background. There is a lack of case studies. There is a lack of conclusive information that may support more specific laws, more specific parameters. So developing criteria is what we do have. It's a very old standard that was set by the Brazilian Association of Technical Standards, and it's from 1997, and actually it was primarily for design and construction of septic tanks for domestic wastewater treatment. And there is an item that deals specifically with water reuse as an option for the discharge of the treated wastewater. So basically it's a little bit old. It's like 20 years ago, and there are not many parameters. The uses, the intended uses are divided into 4 classes: car wash, floor wash, garden irrigation, toilet flush, irrigation of crops and cultures. But basically it's too poor, this standard, and sometimes a little bit too restrictive. For example, when we have the class for car wash, the level of turbidity has to be less than 5 NTU, and total dissolved solids lower than 200 milligrams per liter. So it's fairly restrictive standard. So it's a standard that needs to be updated. And this mission is a quite difficult task to develop criteria because we have controversial information. It's difficult to find a consensus between all the experts, because basically the criteria is also divided into a zero or a very low risk approach, which is followed and adopted by the Californian criteria in United States, which is a reference for water reuse, or an acceptable or tolerable level of risks, which is suggested by the World Health Organization criteria. So as we have these different approaches, everywhere where we have a rule for water reuse, there is a discussion on whether the numeric values for the standards are too low or too high, or which should be the right parameters to be evaluated for a certain intended use. So it's a very complicated and complex task to set this reclaimed water criteria. I would like to show an example, a case study in Brazil, which was a study I performed with some colleagues of the Federal University of Rio Grande do Sul, and this example is in a car wash wastewater car wash recycling system. So this is a very common unit where you can see we have many commercial car washes in Brazil. We have car washes in gas stations. So I think it's a very present unit in our daily lives. And this study was performed in Porto Alegre, Rio Grande do Sul, the very south of Brazil, in an ecological car wash named Ecoagua. And basically this is a very ordinary car wash with capacity for about 30 cars per day, and which uses manual wash with operators manually hoses to wash the cars. So as we don't have regulation on that modality in Brazil, we needed to search international regulations in the reuse of water all over the world. And we observed that, for example, in Australia, in the state of Queensland, in the Netherlands, and in some Scandinavian countries, there are restrictions on the consumption of drinking water when we are washing cars, and these restrictions must follow between 60 and 70 liters per car. For you to have an idea, we use on average 150 to 100, almost 300 liters to wash one single car. And other countries, such as Belgium, Austria, and maybe also Germany, they impose minimum percentage ratios of water recycling. So, or either 70% or 80% of reclaimed water to be used in a wash of a single car. So we try to reach these restrictions imposed by these European countries. And regarding other criteria for reclaimed water in car washes, basically we have aesthetic quality, which means clarified water with no foaming, as it's used a lot of soap in the washing processes, and also an odorless water. We have microbial quality, which means health risks for both the operators of the car wash and also the clients of the service. And we have the chemical quality of the water. So these are the risks of corrosion and formation of the possibility of the formation of spots on the surface of the vehicles. So basically this was the car wash recycling system. So we have basically a car wash pit where the effluent was collected and passed through firstly by a oil-water separation, a wastewater tank, the treatment process, basically coagulation, flotation, sand filtration, and chlorination. And then we stored the reclaimed water in a water tank. And we also had fresh water. We need to use fresh water in the final rinse of the cars because these waters also have high concentration of dissolved solids. So once we have the evaporation of the reclaimed water on the surface of the cars, we may have the spots formed by these salts. So that's why the final rinse has to be performed with fresh water from the public supply. We used the low technology, low cost, and controlled risk approach by using this physical chemical treatment, mainly flocculation, flotation, sand filtration, and chlorination. So using a decentralized approach. And these are already the results of our water audit during 22 weeks of study. More than 2,000 cars were washed, and we were able to get 70% of percentage ratio in the car. So we did comply with some European impositions. We obtained good aesthetic quality, so with a reclaimed water with a turbidity lower than 10 NTU, odorless and no foaming, so we had no complaints from the clients and the users of the service. Regarding microbial risks, as we didn't have reliable limits in Brazil, we performed a quantitative microbial risk assessment that was explained yesterday by Professor Maria Teresa, I guess. And she explained how to perform a microbial risk assessment. So basically we used Escherichia coli as a microorganism, and we used a beta-Poisson model and the tolerable risk approach, which means that is one infection, the risk of one person to be infected in 1,000. And by using this risk characterization, we set microbial tolerable risk at 200 colony units of Escherichia coli per 100 milliliters of water. And to reach this limit, then we optimized a chlorination process, and the optimum dose of chlorine was set at 15 milligrams of chlorine per liter. Regarding chemical risks, as we also didn't have any limits, any standard nationally and even internationally, we searched for a limit proposed in literature, and this limit was at 100 total dissolved solids, milligrams per liter of total dissolved solids. So what we did was to monitor along water cycles. So one cycle of water was considered to occur every time we treated the same volume of our treatment, our reservation capacity, which was 10 cubic meters. So we monitor this, the buildup in total dissolved solids concentration along these water cycles by a mass balance. And we tested two different recycle ratios of 70% and 80%. And then we observed that the percentage ratio was a limiting factor, as when we use 80% of recycling ratio, we overcome these limits. And by using 70% of percentage ratio, we were lower, we had a lower concentration, and so no chemical risks to the cars. And the same we did for chloride, ions chloride, as we use it chlorine. We also need to search for limit proposed in literature for the beginning of corrosion process on the surface of vehicles. And for both recycling ratio, the concentrations of chloride ions were below this limit, so we had no chemical risks regarding also ions chloride. And at the end, we also performed an economic evaluation, as costs are very important, and we assessed the payback of the equipment, the technology used for treating the wastewater. We assessed different cities, different scenarios, as we have different water prices for the different municipalities in Brazil. And we observed that the payback period is dependent on the water demand, so number of washes per day, and of course on water prices. So in São Paulo and Salvador, where the water is more expensive, the payback period may be achieved in periods even lower than 1 year when we have highly washing demand. So the conclusions from this study were that by using the approach of low cost, low technology, and controlled risk approach, almost 70% of odorless, clear, clarified water and safe water was reclaimed, where more than 2,000 cars were washed during 22 weeks, and no problems regarding the wash service quality were reported. We were able to publish the study in the 2012 guidelines for water reuse from EPA. It's an important document for water use in the road. And we had some important lessons learned from the experience of the car wash wastewater recycling study. So first of all, the need for regulation that makes some water use modalities imperative, for example, car wash, as we have in many European countries. So it's very important to have this imperative water recycling in many other activities. The enhancement and definition of standards for reclaimed water for different uses, because we are researchers, but for example, for the owners of these commercial car washes or gas stations, they maybe are not able to look for parameters, standards, and criteria. So we need this well established in our country. We need to a constant monitoring of it. We need a proper sampling, planning of the quality of reclaimed water. And we don't have it, so we need a proper control to ensure the safety of reclaiming water. And we need to develop, integrate, and apply different treatment techniques. It doesn't matter in which approach, if it's a high cost, high technology, or if it's a low technology, but that uses the fit for purpose approach and treatment technologies that are chosen based on the reclaimed water quality that we need for an end application. This is the next conference that I would like to tell you that we have on water reclamation, that will be held in 2019 in Berlin, Germany. So for those who are interested in maybe submitting an article or just attending this meeting, I think will be very interesting, and like overcoming water stress by water reclamation and reuse. So many thanks.
Thank you so much, Professor Ramiro, for your very nice presentation showing the overview of the Brazilian regulations and the another overview and the aspects of seeing these guidelines for water reuse, considering not only centralized but also decentralized systems. So it's a different perspective for smaller units of water reuse and water reclamation. So thank you so much. And following our discussion, this will be the last lecture of today. So I'd like to thank you, Professor Daniel Alasia, because he agreed to exchange his lectures, that it would be today morning. And we had to change because the Professor Mirna had a problem of agenda, so he agreed to exchange. So we thank you so much. And okay. And so Professor Daniel Alasia, he is a civil engineer, and he is also a hydraulic engineer by the University of Argentina. And he has a master and a PhD in water and resources and sanitation by the Federal University of Rio Grande do Sul. He is now an associate professor in the Federal University of Santa Maria, and he works with hydrological modeling and urban drainage. And besides being Argentinian, he's a good person. And would like to invite you to listen for his lecture named Technologies for Urban Areas. So, Professor Daniel, the word is with you. Thank you so much.
So, good afternoon, everybody. I need an answer, so it's a survey. Who is awake is still awake. Who sleeps from now on is my fault. Who is sleeping now is not my fault. So it's an agreement. It's only 253 slides. In an hour and 45 minutes, I can finish. The bad news is there's no still coffee, so it's pointless if you flee away, don't worry, there's no coffee. I like this projector because it makes you thinner, so I like to put my picture on this. So let's talk a little. It's very connected with previous talks, so I'm very lucky to be the last. And I have to beg your pardon, especially to those specialists, because I have bent and twisted some concepts in the sake of facility of understanding. But if you like, we can discuss later those concepts of you can join me in the coffee break and we discuss a little more. It's just an introductory talking, so I will be just, well, let's stop and let's go. We are all sleepy. So urbanization is a big concern, and we were talking about this. We have several mega cities, and Brazil has 15 cities with more than 1 million inhabitants, so they are very big cities with very big problems of water scarcity. So whatever we can do to solve this problem, when we have problems with water, it's not only scarcity. Sometimes we have problems of flooding, that's excess. What we were talking in the last and previous talking. So what's a city? Okay, conceptually I'm an engineer. Engineers, you know, simplify everything. And so a city is basically just people, environment, government, and services. That's a simplified way of. So what we are going to discuss a little is how they interact to each other. And every city today has several challenges. So, for example, how to reduce the use of energy, mainly in buildings and transportation. how to make cities climate neutral, how to reuse urban waste. What we were talking is not reducing nutrients, is not wasting those nutrients, reusing, incorporating them. How to keep water and air clean and healthy, how to make cities green and biodiverse, and how to connect this to human well-being. How to diminish the city negative footprint on area and people elsewhere, how we spread social equity. And equity means not only everybody receives the same education, but everybody has the same opportunity to reach the goal after. And then we have to deal with very short fundings in those cities and problems that our population is aging. So this will cost more in the future. And some countries like Brazil, that they are changing their care system for the old people, their pension system, so this contract that existed that the new will pay the pension for the old is no longer valid. I do not know how to pension in the future, but that's another point. So how we solve this? What we listen in the last day is what we are using technologies of 50, 60, 100 years ago. The rational method for urban drainage has 150 years, more or less, now. The septic tank is 150, 200 years now. So those technologies are no longer valid. We have seen here of toxicity, every single chemical products coming every year, and we don't know anything of interaction of this chemical. So what we need for the future, we still don't know. And we still need to establish how to measure this, how to establish standards of what is acceptable or no. We have seen plastics. Oh, we need to take this plastic. Which plastic? Big plastic, micro, or we have the problem of nano. Thank you, Professor. And so we need innovation. We need new ideas. And new ideas do not need to be something like an app in a computer. We can stimulate, we can get ideas from nature, and we can use nature on our favor. So I'm going to tell you some technologies that you can use and some points. So we are going to talk about environmentally friendly technologies that we will use some communications. Communication is part of everything. We need to talk, we need to exchange ideas, we need to take. So these technologies have the potential to affect economic and social value. If we value more a park or we value more a building. And this changed a lot of things in a city. And this should be supported by consensus. If I want to change the world, I can change locally, but if I am the only one to change, that's produced very little. So we have to convince other people, and the city might accept this solution as a good solution. And the most important thing is you can see a lot of these technologies are in YouTube, are in the website. You receive WhatsApp every day, a new video about this technology. But the point is, you need to adapt this technology to local climate, to local activities, to local ideas. Otherwise, they won't work. I will show you some examples. So far so good. Anyone is sleeping? No? Okay. Just don't snore. So ecotechnology is a science, not just a YouTube blog. We try to understand the structure of processes and societies and use engineering. Engineering is use the engine that God gave us in our heads to solve problems. Então, to adapt these processes we see in nature to help out solve some problems. And the idea is to get sustainable development. So, ecotechnology has a cousin. Ecotechnology is the poor cousin. Because I talk this, because it uses normally cheap and friendly technology. But I want to just use one slide to talk about smart city. That's the next revolution. We live in a world of hundreds of sensors. A cell phone is a sensor. Someone takes a picture of something, and that tells us a lot of things. And when we combine these sensors in a computer, in an intelligent manner, we can produce outcomes. And these outcomes can solve things. So in the next years, we will have these sensors giving us information on rainfall, flooding, bumps, accidents, the speed of the cars that are going. And this smart city revolution is going on in some cities. And the same way as I am talking of eco-technologies, and a previous talking has been, these technologies are complementary. You won't use them isolated. You will combine them with other technologies. This smart cities technology that's coming, also important. You don't know, but several cities in the US, for example, when you go with your car, very soon, or someone is exchanging information and say, oh, the mean speed of the cars in this way is that. So let's adapt green signals to speed up this line. So this information is already going. But a point in South America, and I think in all emerging countries, how much does this cost? So to build up sensors, here in Brazil, for example, we are talking a rain gauge plus a level gauge. We are talking about 5,000 euros. That's too expensive. So we are researching in the south. We are researching, for example, some cheap. And this is good because these platforms for experimenting, Raspberry Pi, BeagleBone, Arduino, they are something very cheap. With something like around 25, 30 US dollars, you can produce a water level, you can produce a rain gauge, and this can be done at poor communities, this can be done at schools. So it's a way of getting information, because one of the things I listen is we don't have information. Normally we need to produce the drainage system of a city, to project the system, and we don't have information. So this line of sensors, cheap sensors that, as Google show us, can fail, and don't worry, we have 100 other sensors that we can combine. The future of us will be how to rely on which sensors, and that's another question for another talking in 5-10 years. Let's come together to this. So let's go back to ecotechnologies. So it's the sustainable use of water resources. What are these technologies used for? Sustainable use of water resources, pollution control, recovery of green areas, control of desertification, maintenance of climate conditions, flood controls, habitat recovery, and so on. I will show you some specific topics. But for example, for plastics, if you want to Google, you have some of these eco barriers that are some floating barriers on rivers. They are normally placed with a bias to the flow, so all the floating debris goes to one side and you collect them. So this is an eco technology. I'm not going to talk to you about it, but you can Google it and you can ask it. I can point you to some specific example of good use of this technology. So some examples. I like the toilet. I think this is very comfortable, especially if it is drying. The cloth at 4,000 revolutions per minute, it must be very funny. So I'm going to talk a little more about urban drainage. That's my expertise. And we have tested several of these structures already, have several of these technologies. I'm going to mention I have a spy in the middle of you, and I'm going to identify the spy in the middle of the presentation. Don't worry. Look around you, the spy could be everywhere. So, what are the urban impacts on the urban waters? We have a natural system. When it rains, most of the rainfall or infiltrates into the soils or comes back to the atmosphere by evaporation. And then we build a house, we get rid of this green vegetation, we get impervious area, so whatever was evaporating is no longer there. We have less vegetation, and water cannot get into the soil. So whatever was doing this now is going on surface water. So it comes to 6 times more water that was previous. And waters reach a point 10 times faster. So this is a damage to the nature. And what happens is natural rivers cannot take into account this 6 times more water is coming. And this causes flooding. But this is not the only problem. In the beginning, we settled around the river. In 1600, Sao Paulo was something like 20 houses. Now it's 20 million people. And so people, I discovered how to do this. It's this way. I am having a problem with technology today. So we have people that start living around stream, and somehow their stream is not enough for the waste. Yes, everybody in a city pees and poos and everything, and when the soil is not enough, it reaches the stream. So when this is too dirty, we get rid of the river, and what we have done in Sao Paulo, we created wonderful avenues over the rivers that now we are trying to get back. But the problem is not that. We have seen Oscar telling us that less than 40% of the sewage is collected in Brazil. Around 20% is treated, and mainly in Sao Paulo. So if we take Sao Paulo, it's good, but the standard deviation is too big. Numbers in the south or in the north, numbers are extremely awful. And this wastewater that reaches the streams, then it is the water we take back. And we have seen here that even with our treatment of 50, 60 years ago methodologies, it is not enough. So apart from point pollution, we have diffuse pollution. So in Brazil, normally the first part of the rainfall that cleans all wastewater everywhere, remember cats and dogs has no bathrooms, it has more or less the same concentration as sewage, or worse. Other problem is garbage collection is not good. So when it rains, we have a lot of problems of this garbage reaching our structures. This is one of the piscinoes that we were talking in the first talking in the morning. And so not only they are ugly, they are where all the wastewater is reached, all the waste, all the garbage reached. I will show you one picture. It was not combined, but here. This is in Guatemala, but I have some pictures, similar pictures in Manaus. It's a river of plastic. Macro, it's, yes. Everything. And more things. Yes. If you can Google, I suggest you from Mexico, there's a diver of the sewage. It's one of the unique things in the world. It's very interesting. He dives inside of the sewage system, taking all the problems. When it clogs, someone needs to unclog. So they sent this guy in Mexico, and he said that he is the last because nobody wants to do it. It's very interesting. Just Google it. So we have problems with erosion. There are no regulations in Brazil for erosion on building sites, and these pictures are from Brasilia after rainfall. This is another part of Brasilia. A neighborhood was built. They did this. They put the drainage water, and erosion is not my problem. It's of the next neighbor. And this is Porto Alegre. Porto Alegre spends millions of US dollars cleaning their rivers because they do not control this. So another problem is we have some colleagues that do not have glasses. So when they solve their problems, they create our problems. So this is very common in Brazil. This is from Brasilia, the capital, 2 million people. This is, I think, from Belo Horizonte. This is Brasilia also. And so we have several problems that someone's developed its project and doesn't care what's there. This is Porto Alegre. These buildings were perfectly built. But the problem is that the river, the stream was all of this section. They kill half of the section, but that's another problem. The road is working fine. And what happens, how this could happen? In Brazil, normally who wins is a coalition. And these coalitions says, oh, this secretariat is for you, this secretariat is for you, so different parties get different parts of the government. They don't talk to each other. So this is what happens. They build the bridge, and if someone says, not because this is half of the bridge, who is going to stop our building? So this was a very big problem. And where do they have flooding now? Here. So they don't care. It's 200 million that they need to be rebuilt later. And other problem in Brazil is the lack of zoning. So this is a very well-known city close to Paraguay in a normal year in the 83s. So what happened? People forgot that they lived close to a river and that sometimes rivers wake up and say, this is my land. So the consequences are there. I won't. So let's talk about solutions. Any questions? Someone needs to be awake. No coffee yet. Yeah. We are in a 10th of the presentation. I told you it's 200 slides. So what we need? Adequate technologies, environmental friendly, efficient, adapted to local conditions. So again, I will reinforce this. You can take my presentations, arrive there and say, oh, I seen what they do with these milk boxes. This is amazing. Check first. It should not work. So you need to put science over this before using. Otherwise, you will say, this does not work, so it's useless, and you are wasting a very good technology. And should be economically viable. Some time ago, some colleagues of us went to Japan, And they come, oh, we need to build this structure, this other structure, and they say, we don't have billions. So you have to lower your expectations. So this is good, this transfer of ideas south to south, it's very good. And there's another question. Soils in the southern hemisphere are normally totally different from soils in the northern hemisphere. If there is someone from soils can help me, but these come from Pangaea and Eurasia continents, so they develop in different ways. So normally, models that works in the northern hemisphere could not work in our countries. And sometimes we adopt these technologies and we cannot even test because models are not working. So we need to exchange more ideas south to south. So we need an holistic vision. Yes, we need to talk. So zoning, I'm not going to enter. Why this is eco-technology? Okay, let's do zoning. 30 meters or 100 meters around the river could not be used. But the thing is, we will let the forest grow alone or we will help it. How we will help it? Perhaps there were 100 or 1,000 species before. If we help them, normally in Brazil they select 5 or 6 species and they plant around the river. So we think we are doing something good, but in fact we are killing biodiversity. And today could be good, but in the future there could be some disease that kills all these plants because of no variability. So we can use soot and leads. You will see that my presentation mixtures a lot of LIDs, low impact development or sustainable urban drainage design. So I beg your pardon, but that's deformation because it's my area of expertise. You can just ask people not to let the water reach the street. You need to go through the earth, or you can use permeable pavement, or you can use soil infiltration trenches. Those are very cheap solutions and work fine. Here in Brazil, they work fine even in very clay soil. Why? We are in a tropical climate, so we have a lot of bugs in the soil. So if you look at North American or European regulations, they say clay is bad. But here our soils are totally different, and we are working with soils that are unthinkable for Northern Hemisphere solutions. So, but one of the eco-technologies I like the most are the ones that uses plants. So there are I will leave this for you, because they are environmentally friendly. I am doing some marketing of plants today. Join us. Environmentally friendly, great aesthetic appeal, profitable. We have seen here that someone was doing constructing pellets from biomass. Low investment costs, and especially important, shouldn't be used alone. This is someone you need to combine with other technologies. The use of green infrastructure does not avoid the need of tube, pipes, drainage system. It is just you combine the ideas. So some of ideas, this is just for you to keep in the PDF. And one of the solutions I'm going to talk a little is about wetlands, constructed wetlands. So we've been using wetlands for water quality and for water quantity. We lower the hydrograms, we clean. Some research on our university have removed 80–90% of pollutants. Okay, we need to recycle them, but so far in Brazil, if we can clean them, it's just a good step ahead. And a good thing of wetlands that I like most is we have very good result with some medicines, with ibuprofen, caffeine, and it's for headache also. It's paracetamol. So we had very, very good results with them. And with other techniques, not this idea. Also, we can use them for remediation of contaminated soils. So there are several plants that through them or because of some bacteria that get in conjunction with their roots can treat these soils. You know? Even I found some examples for petroleum. That was not in my expectations. And also recovery of degraded areas, control of the desertification processes. We have a lot of these in the northeast of Brazil. If you go to Natal, I recommend you, very good place to go. You will see this control of dunes. And erosion control. For erosion control, I will stay a little because we have done some erosion control in the university. In the university, we have expended a lot of money because we have this stream that has been urbanized. It's a neighborhood of the city, comes all through, goes through this stream, through the university. We spend a lot of money, and every time water comes faster and dissolves what we have constructed. So we constructed a criner wall. A criner wall is we plant some species. 3 minutes. No. I need at least 30. Okay. And it's been working. In just 3 months, we have been covered. We have good floods, large floods, and it has worked. We have swales that retains green walls. So now I identify my spy. That's Paula. Paula has been working with these swales, and we have at least 10 degrees difference between the swale, between the place we have construct these and cover place. And this is very cheap, and the idea is we have used plants that in winter they lose their leaves, so you get more heat in the winter. Permeable pavements, I will have to run because they are. You're not going to kick me. Yes, he's going. And green roof, so we have a lot of research on green roof. We have for 10 years research which is the best species, because a green roof species should be good for capturing water, but should be good to resist drying conditions. Otherwise, we will need in a draft to go over our roof and give water to our plants. So we come to some solutions very good. And we have also, and this was also Paula's work with milk boxes, constructing green roof tiles. We are still working on this, but we have also worked with milk boxes to isolate homes, poor people's homes. This solution has been applied for Engineers Without Borders. They can lower 8 to 10 degrees the temperature inside of a house just using milk boxes as a cover. So we can talk about bioretentions, replacing hydraulic elements with infiltration trenches, bioretentions, and other technologies, rainwater harvesting, solar heater, the poop loop that we were talking yesterday, and I'm just going to talk a second about this solution. It is called here the bananas septic tank. I don't know exactly the translation, but it's something like this. So we use old tires, or could be constructed an anaerobic chamber. Over this we plant something with big leaves. Bananas are the ideal candidate. And we send black sewage here, and it works perfectly. We are monitoring one for 9 years now to be used with very contaminated rainwater. And there's another constructed in a house, and they are working fine. We also have for grey water what it is called a circle of bananas. This is how it is constructed with waste. And it is not working as well. We have tested in the house to change detergents, to change soap, but still we cannot find exactly why it is not working, because it should work. So that's a point I'm confessing, for example. You try to adapt a solution and it may not work in your area because detergent has a specific enzyme that kills your vegetation. So, look, time is over. Ha! I want my prize. I was off. And look, there are still the 3 guys who were sleeping. They are sleeping, but no more than 3. So, thank you very much. I beg your pardon for my English, but I'm available for questions.
So thank you very much, Professor Daniel, for telling us about the current problems in urban areas and also about these environmental eco-friendly technologies. I'd like to give you a message that for all the ones that are going to the technical visit on Saturday, you must give your name on a list. Only the ones that are going to the visit on Saturday, okay? So you must give your name during the break for the people outside.
Can you explain what the visit is going to be, where it's going to be?
Maybe may invite you, Marcelo, that know the region, to explain a little bit more about the visit. Yes. Só como vai ser, não sei como é que vai ser a visita.
Okay. Regarding the visit on Saturday, just a few words. It was planned because it deals also with our topic. That means 60 years ago, São Paulo used to be a city of medium size compared as it is now. And it was built a large reservoir here in São Paulo, almost 800 meters, to provide hydraulic energy for the industry at the level of the sea. So we are 800 meters high from the sea level, and the sea level is just nearby São Paulo. So it was built, the company of energy and water of São Paulo built, his name is, the engineer is Henry Borden. He was a British engineer that came here and they made this construction, and the reservoir name is Billings. So this reservoir discharge water to in the huge tubes channels, closed channels, unto the sea level, and there is a generation station that use this water. The problem is São Paulo start to grow since the last decades very fast, and the same reservoir, by the law, it should be the priority to water supply. So the city now is São Paulo, 12 million people, in the Great São Paulo is 22 million people, and when there is, during the no rain seasons, the dry seasons, the level of the reservoirs decreasing, but they still keep using this for energy supply because they sell the energy, but by the other hand, by the law, the water sanitation company used to withdraw, to distribute to the population. So we are going to visit at the sea level, where is this old energy generation, and if we had time, we could see the reservoir as well, but I don't know if we have enough to do both, because we have to take another road to get down. And then we go to visit that place, the installations, and around where is near we call Parque Serra do Mar, and then we have a lunch by the City of Santos, that is, it's by the beach, yeah. And then we come back just after lunch. That's the idea. I wish we could have time to walk around as well, but let's see if it works. Do we? Great. Okay. Let's walk, sure. Any question regarding this? What I need is most of people already sent the information because we need for security for the company to have all the full name and passport number, or the Brazilian individual identification. And we need to know exactly the number of people that will go to this visit on Saturday morning. So we should arrive here in São Paulo, I believe, before 4 p.m. We'll be in the hotel or around. So after, we are going to get coffee break, but when you be there, please stop by with the students on the desk just to confirm, because we need to confirm, because some people have to travel at the same day on Saturday, and people that have to be in the airport by 6 p.m. I think it's a little bit risky. I mean, of course, we should be here before, but in the case of someone have to be in the airport by 6, it will be maybe in their decision to go or not, but I would take care of to manage to be here before, but we never know if you have some problem. That's all.
Okay, thank you, Professor Marcelo. Thank you all. I'll invite you all for a break now. So 15 minutes for a break, a cough to wake up, and after we come back, invite the lecturers for some questions, so you can prepare your questions, write down your questions and the doubts. Okay? Thank you so much. See you soon. Well, welcome back from the break. I imagine that you were discussing, writing down your questions, and discuss about the lectures we had previously. So I'd like to invite Professor Norbert, Professor Ramiro, and Professor Daniel to come to the stage here. And so we can continue our discussions about these pollutants that you can find in waters that are recently being calling our attention, and possibilities of treatment, water reuse, and also some technologies that you can apply in urban systems. Oh. So I'd like to open for questions now, for any doubts that you have about any of the lectures you had previously. Please. No questions?
Everybody is tired.
Please, microphone. Okay. Can you speak slow?
Professor Elvis, if they don't ask, we can give a test to them.
Good.
Oh, yeah, good idea.
Good idea. Yes, we can ask them.
Write a test.
I have a particular interest in micropollutants, and especially micropollutants, like contaminants or emerging contaminants, as we saw in the term. In your speech, there's some link with our work here. I worked with evaluation in emerging contaminants. We evaluate bisphenol A.
You are not loud enough. I'm an old man
sorry.
with bad ears.
Now it's better.
Yeah.
And we evaluated in our study bisphenol A, for example, removal of bisphenol A. For instance, in Brazil, in 2011, we banned the plasticizer bisphenol A for bottles of children. I don't know in English the name, but especially the bottles that we gave milk for children. Just in this case, the Agents for Health in Brazil banned bisphenol A, but as far as we know, we have a lot of another plasticizers and micropollutants. WFD, the Water Framework Directive from European Union, did some advances. For instance, establishing maximum levels for bisphenol A, disruptor endocriners, and the kind of things. My question is, how is the framework right now for European Union in respect to establish maximum levels or banning some kinds of plasticizers and another micropollutants? I try to explain my...
So in the European Union, we have a discussion now longer than 3 years about banning plastics for different purposes. The problem is that the politicians do not listen what the scientists tell them. That's the biggest problem. I cannot say what the politicians will do this year or next year. Sometimes I was part of this discussion with the politicians on the level of the European Union, and I will give you a different example. They banned, for example, simple electric lamps 5 years ago in order to bring the new technology in, and it worked. And hopefully they will also ban plastic material for different purposes such as bottles and so on, because you can use glass that's as cheap, nearly as cheap as plastic, and it's 100% recyclable. But what they will do, I cannot say.
Okay, thank you so much.
It's a difficult solution. Now we don't know if you don't have questions, we may propose some questions for you, right, Professor Daniel? Oh, okay.
Yeah.
But I think even in Europe, the number of emerging contaminants that are monitored by the European Act, I don't know that legislation. That
Yes, actually these...
That is only less than 100
Yeah.
of substances.
But the only rule now is to monitor it. There is no limit.
In drinking water, right?
Yeah. But in the national regulations, there you have limits. Yeah?
Okay.
But not in every
But they are
country for
quite-
all the 100 compounds.
But they are quite generic, aren't they? They are like, for example, I remember for the Dutch legislation, it says anthropogenic compounds. And then the limit is, if I'm not wrong, 1 microgram per liter.
So,
but then it's quite generic because there are some compounds that do not present risks at such a low dose.
I think it makes sense because in former times we had limit values according to human beings. We want to protect ourselves. But the new idea is to protect the ecosystem. If you want to protect small animals with a weight of 0.1 gram, you need such low concentrations. But that means that potable water is not allowed to be discharged in rivers.
Yeah, sure. Because it's a cycle. It will be
Yeah.
back again.
And I have a little doubt about the political thing that Professor Norbert has just talked about, that we saw that the academics and the science are putting a lot of energy to develop and to consolidate this holistic approach regarding water security. But as has been mentioned, many of our research results cannot be applied due to political interests. So in my state, Pernambuco, which is the driest state in Brazil, we have this big challenge. So my question is, from your experience and point of view, what maybe can we do to put the environmental agenda above the political one, if it is possible to do it in our current situation, as we are in a election year?
So vote the party who will do the best for the environment. That's the only thing that's possible. But even if you do this, you know, in Germany we have a Green Party. They started 30 years ago. At that time I was a member in this party. Nowadays they are in charge and they are powerful and they forgot most of their green ideas.
How can you realize or compare the solutions or the problems that were discussed here today with your region or with your country, with your localities, and compare if you have the same problem or if you have found an alternative for the treatment, considering all everything what we have discussed here today?
Question
Okay.
for Professor Deshtin.
You are the target.
I'm confused because I'm thinking about the microplastic pollution. It's very, very huge amount all over the world. And what is the proper solution for this problem? If we talk about bioremediation using insects or microalgae or phytoremediation, we have to think about the food chain and the bioaccumulation process and like this. We are not solving the problem of pollutants control of microplastic by using the bioremediation technology, because it's affecting another the life, another part. We just remove the plastic from the environment and put it in the life cycle of the human animals and plants like this.
No, I think if we remove all plastic material from wastewater, we solve a lot of problems concerning micro and nanoplastic. If we would be able to take it out, that means we have to incinerate the sludge.
Yeah.
Otherwise, you are right. But if we incinerate it, we get rid of the problem. Up to now, we found a lot of microplastic, especially in shrimps, lobster. You should avoid to eat too much of it, because no one knows what it affects.
If we also, if we did some research on pigs
Yeah.
or insects in the future, would be the source of protein for humans. So also
Not for me.
wax. The Chinese people eating it.
Yes, I've been there
Yeah.
last week.
Yeah.
I already ate insects. Yes, I tried them.
So the larvae of waxworm is also can be used as a food, and it accumulates this plastic in its
No, not
tissues.
in the waxworms. There is no plastic in. They really destroy it.
Destroy it.
Yeah, to carbon dioxide.
Protein?
Yeah,
Yeah,
really.
that's good.
That's interesting, but our knowledge is very small about this. Let's wait another 4 or 5 years.
We did research on this. Thank you.
So, but there are also 2 other professors or 3, not only me. I want
You
to
can
discuss
share.
with him
Oh,
a little
good,
bit,
good.
yeah? Because I
may
cannot agree with all you said in your presentation. I'm giving lessons at the University PUC in Rio de Janeiro, and since now 12 years, I think. And very often I was asked by the local authorities to discuss the wastewater problems with them. Yeah. And they always told me, no, professor, impossible. We need innovation. We need new solutions which are much more better and very cheap. And that was exact the first topic of your speech. I want to ask you, what do you understand by eco-technologies exactly? By green solutions? And I want to know whether you think that human beings are a part of the ecosystem or not.
It's very complicated. It's something like fail tests.
But you had more than 200 pictures. So.
Yeah, I'll have a lot of pictures. That's nice to wake up people. And, okay, humans are part of the ecosystem, yes. One thing when we say we need to protect the ecosystem, that's the most tricky question or the most tricky assertion you can do. Because the thing is, what we want to protect. We want to protect all the ants in the world. Perhaps when you walk here, you kill 10 ants. I think my conscience can live with that. So we need to establish what is acceptable risk, what is acceptable killing or not. And who defines that? It's humans. The only just one part, okay, we are 6 billion now, 7 billions. But we are not the only ones. We are less number than insects.
Really?
So who defines? We decided 50 years ago that plastic was good. And now we decide that it is not. And that's another problem. The idea of peoples about nature, of what should be protected, what is good, what is bad, change with time, with culture, so it's a very, very tricky problem. Our politicians here want to deliver everything for almost no cost or no cost at all. So there is no free lunch. That's the first thing I tell them. What I have shown is some technologies that are cheap in one sense to construct them, for example. This craner structure we constructed, we use it almost, we buy nothing. We use an old eucalyptus, some bamboo, and some vines we collected from a neighbor river. But we use a lot of manpower. It took 3-4 days. So it is not free. It costs. We needed gasoline to get this truck.
But excuse me when I interrupt you. Do you really believe that your pits with bananas are a solution for megacities?
No.
Okay.
That's why I introduced a slide of these smart cities and so on. These are good for rural areas,
Yeah,
when
okay.
we have a space. What is that was my continuous. In cities, what is the most expensive thing? Sao Paulo, Rio, everywhere, space. So we rent space. When we construct a sewage station, we are renting space. I am getting rid of the septic tank and I'm renting space somewhere else. So I'm paying to someone solve my problem because I want that space that costs a lot. So we will need better structures in megacity, not this technology. These technologies, it's, as I say, complementary to some. What I was discussing, I hate the word alternative solutions or alternative technologies because
But you
every
use it.
single one is alternative. Which is the best for each solution? Could be a high tech, could be a low tech. You need to do eco-engineering. Use engineering to decide which is the best solution. So perhaps in a mega city as São Paulo, not a centralized thing, but a thing constructed to work in a very efficient way because it costs a little more, but you save a space that perhaps is the most expensive. Another thing in South America you need to take into account when constructing things is maintenance. We do not apply maintenance to anything. It's thousands of examples of something that is built and in 5 years does not work. So solutions need or somehow to assure maintenance with a contract with a private firm or something like this, and get rid of politicians that change minds or need to be free of maintenance. So which are these solutions? And which is the problem? Politicians are elected by us. And now I'm coming to plastic a little. Give me just 1 second, I'll give you the word. Yeah. No, it's 10 years ago, there was a law in São Paulo that was passed to get rid of plastic bags. Do you remember? It was almost a revolution in São Paulo. I never seen people so angry. So in less than 2 months, they get rid of the law. I think that they were going to give an impeachment on the mayor, and this law was forgotten. They did this same law in the Patagon, in Argentina, and in the Patagon in Chile, and it worked perfectly. What was the difference? Perhaps in the Patagon, they did a campaign first, informing the people what is the harm to because people sometimes take decisions according to their belief, not sometimes, always to their belief, so they need to teach them the right things. So the law that passed easily in the Patagon has not passed here in São Paulo, and there was a revolution. So that's another point in how we will get rid of plastics. First, education. Then we can go for high-tech, low-tech, eco-tech, and green-tech solutions, maybe. Sorry.
I agree nearly. Not first education. We have to start with education, but at the same time, we also have to find solutions,
Yes.
point by point. And what I criticize in the situation in especially Rio de Janeiro is that since 30 years, they are discussing the problems of treatment of the wastewater, and they don't do it only a few.
Still discussing.
And just for you to know, the city we are living with Elvis, in Santa Maria.
Okay,
In
I know it.
2002, I was just a master's student, and somehow my colleague was working on the sewage station of Camobi, the neighborhood where the university is. We are in 2018, and I think that I have seen 3 projects of the station, and it is still has not been work. So they pay 3 projects, they spend millions. So that's our politicians. like to discuss, but when it comes to implement, they do not do that. Or when they come to implement, they discover that the project is not good. And we have a lot of problems here in Brazil. You can't imagine this thing. And again, I beg your pardon, I tell you, that I was twisting some concepts, I was bending some concepts, but eco-technologies are not panacea, will not solve anything. Several of them are only possible, most of them, if you have a space. Yeah. And space in a mega city like Mexico, like São Paulo, or India. In India, it's the most expensive thing you may have. So it's good, could be done, but you need to know if you can adapt it to local solutions. So we need, as Professor said, we need education on one side, and we need to investigate which is the best solution for each place.
Okay, I agree.
Yes, it's interesting to think about some decentralized solutions or small solutions even, because considering the Brazilian situation, it's very common to find places even where we live with irregular urbanization or irregular houses, slums, that they simply discharge the sewer into the rivers, the sewer into the basins, to where we do the catchment of water for water supply. So when we catch this water for water supply, we go for a conventional water treatment with alum sulfates, and at the end of the treatment, we do not remove so many things that were introduced, like pharmaceuticals, hormones, or fertilizers, and this cycle continues. New sewer is generated, goes to the rivers, we catch the same unplanned, as was told here, unplanned reuse for potable purpose. Besides, Brazilians they have a regulation that says, no, it's not possible, we have enough water, but we do this. So, considering your speech about these advances, this overview about the Brazilian regulation, Professor Ramiro, I'd like to ask you, do you really think so that they will overcome the situation, that they will develop or plan some regulations considering the direct potable reuse? What do you think?
Yes, I do believe in direct potable reuse. I think it's fantastic, this idea. But I agree with, I'm also one of the main interested in water reuse, but I agree with something that Professor Miesva said in this morning, that we have easier solutions, but I would say that we have more priority things to be done. Like, for example, we don't have basic sanitation. So, of course, we need to have an eye towards the future, but we need to solve basic problems. We need to collect our sewage, we need to treat our sewage, we need to reduce wasting of water, we need to use water in a more rational way, we need to improve our technologies, our techniques, and of course we have water reuse, we have the issues on emerging contaminants that are also very important, but I think maybe there are a few steps before that we should prioritize, like this, as the main things. But I believe that potable reuse is the future, as we already perform an indirect and planned reuse of water, and maybe if we plan it, it's going to be cheaper if we use the same distribution systems, if we mix decentralized and centralized options, depending on particular characteristics of cities, of regions. But I do believe.
So I think there are examples worldwide. In Windhoek, for example, they have a mixture of natural water and reclaimed water. As far as I know, I visited this plant once. Perhaps you have more information.
The thing is, you can't drink treated wastewater directly. You have to blend it because everything is taken out. In reverse osmosis, there is not enough macronutrients and what
Yeah.
in that water to drink. So it's never, except for the advert for the Prime Minister of Singapore, water. There's never a situation where that's the only source of water that you can drink. But yeah, Windhoek has been going for 50 years. Singapore is doing it. We have towns in South Africa that have now got projects
Yeah.
in use. I think the big thing here is there's no such thing as wastewater, and that's what we need to move towards. We keep still calling it waste. It's not waste.
Yes.
No, it's reclaimed water.
It's source water.
Yeah, I mean that's
Singapore, they call it new water.
new water.
Yeah.
And we also have new water in South Africa from both of which.
Sorry, but I missed what you said about the nutrients. We've always...
It's more the, it's not nutrients, what do they call them? Minerals in the water, because
Minerals, oh, all right,
it's taken
okay.
out with the reverse osmosis or treatment system. In Windhoek, they don't use RO, they use ultrafiltration. But it's the same thing. You have a very, very small membrane that, you're allowing nothing through. So it's almost very, very pure water. It's almost distilled water by the time it comes through that process. And we would not, thank you, sorry. We would not survive if you only drank distilled water. You have to have a certain amount of minerals in your water. So that's why they blend it with groundwater or surface water.
In an environmental buffer. Like
Or you
was
can add it
used.
artificially.
You
That's
can-
also possible.
I guess it is. I'm not sure if there are
I
any
think that's the
cases
function of
that.
these buffers.
So if you think about this station in the, I don't know the English word, which is surrounding the world, with the cosmonauts and the astronauts, they are always drinking their own water.
So maybe they add
Yeah.
minerals and nutrients.
Yes, they clean it up and add minerals.
We can supplement, maybe.
Plastic.
No plastics,
No.
please. I hate plastic.
Plastic free. Yeah, the idea is to solve the basics, sanitation, like I said, especially in developing countries, but to start to change this idea, to see not like wastewater treatment plants, but like water resource recovery facilities. Like Professor, we had a lecture yesterday, he said that he see the feces like source of nutrients. Like you said, the wastewater is a source of nitrogen, phosphorus, and you need to recover it, reuse it for other purpose. And
solve these problems with an eye on the future. So, as we need, for example, to build more wastewater treatment plants, why not to design them to remove these target compounds, these metals or other plasticizers and pharmaceuticals and so on?
So in Europe, perhaps you know, we have actually a long-lasting discussion about residues from medicine.
Mm-hmm.
So at first, the Switzerland authorities started. They decided to equip the 100 biggest wastewater treatment plants with a 4-step of treatment, whether activated carbon or ozone, in order to destroy pharmaceuticals. In my opinion, completely wrong, because they take 100 big wastewater treatment plants, which have big rivers where they discharge it. But the problem to have the small rivers in the rural area where a lot of old people are living, using a lot of medicine, so it's completely nonsense. And in Germany we also start to build these plants, but we don't have that much experience. We try different methods and different sizes of the wastewater treatment plants.
A discussion we were having in our group, our president of the group is there, yesterday was about this thing of micro pollutants. In the future, we will have several standards. Dialysis is a good idea. Someone who is doing dialysis needs a more ultra pure water, not the same we take. And someone that is immune depressed, the same thing. So we will have one standard for almost everybody, and some people will need an extra purification for their needs. So these reclaimed waters we will need. So we will have something like, that's my idea in the future, a general plant for nutrients, you said the word, nutrients recycle,
Recovery.
and then these waters that remains will go in a general form, and locally we will need to treat them. And in the houses, something like this is what comes out of the house for certain people will need to add some treatment, pre-treatment. How we will do this, how will this end up, we don't know. We don't know the medicines of tomorrow. We know the medicines of today. So it's a challenge, a very big challenge. And my concerns are here in the third world. We are not convincing politicians, we are not convincing the people to adopt already known solutions. How we will convince them to add activated carbon to sewage if we only treat 20% of sewage?
I think in the future we will have better medicine than now. I will give you an example. If you use diclofenac or ibuprofen, it has in most cases the same effect on you. But ibuprofen is biodegradable, diclofenac not. And the pharmaceutical science try to make a composition of medicines that is biodegradable, more or less. And I'm pretty sure that they will be successful.
Yes, but we have, by the other hand, a lot of chemicals that are released every month, every week. So I think that we still have a challenge.
Sorry, you know how many chemicals we have in the international market?
How many?
50,000.
50,000. There are 160 million chemicals.
Okay, that's not a difference.
A student of mine made this research.
Yes, and considering, imagine these new chemicals, new challenges being released into the rivers, and it will return us, give us some effect. It's really a public health problem that we may have. If you compare with the diseases, cases of cancer and other things, like we discussed yesterday about the analysis of risks. Today you showed us a little bit about the risks considering these problems. So it's not an easy task to solve.
I think that the question that humanity will have to answer is, okay, we live much longer than a millennia ago. We live better. I think that's the question. We need to live better. And to do that, we need ecosystem. Ecosystem needs us. That's the point.
Okay.
Okay.
Any more questions? No? So I'd like to thank you for the lectures, Professor Norbert, Professor Ramiro, Professor Daniel, for your valuable time to be here. And I'd like to ask for the working groups to continue working now. You have the challenges that we gave you yesterday. You have the materials that we gave you yesterday. So today I discussed with some people, some groups, and they said they were working. You are keep in touch, discussing about these challenges that you have, the problems that you have. So I ask for each working group to get together now and continue what we have decided yesterday. And if you have any question in particular, you may call me and you can.
I just want to clarify, what is the purpose of this? Are we trying to highlight what the challenge is, and then are we trying to highlight the challenge and then come up with some sort of proposals to address it?
Yes. The idea is to show the problem because each group has a different problem.
Yeah.
Let's say.
Yeah.
So you need to say what is the problem, compare it with each of your regions, if it's a local problem, if it has in other parts of the world. You read about the diagnostic is there any solution for this, what would you propose to solve this problem, is there a solution or not. What is the role of governance, society, scientists, sanitation companies, and this is the idea. So each group will work on it, and tomorrow you have like a 10 minutes to show up a slide presentation. The leader will present it. So you can continue now, and tomorrow morning you can. By the end of the morning, you can present these diagnostics that you found out.
So we will have time for the test anyway?
Yes, you have the questions, you can distribute.
200 questions.
Yes. Okay, thank you
Ramiro,
so much.
don't you want to change your questions? I think that are too difficult.